Now this question 9.7 of NCERT, it says double convex lenses are to be manufactured from a glass of refractive index 1.55. That means you are given the refractive index of the glass, that is the material of the lens, with both faces of the same radius of curvature. What is the radius of curvature required if the focal length is to be 20 centimeter? So here what you have, both faces have same radius of curvature. That simply means the magnitude, because you know one would be positive and one would be negative. So if I can make it, let's say it's what we call as equiconvex lens. So it would be an equiconvex lens. Wait a minute, let me draw it properly. It should be like this. Okay, so this is an equiconvex lens. What we say, the both sides have the same radius of curvature. So that means the magnitude of both is r. Now here what you are given, the focal length ultimately coming out, because it is a double convex lens, nothing is given, so you will assume the surrounding medium is air, and since it's a convex lens you will take focal length as plus 20 centimeters. So you can write given focal length is this. Now using the formula that we know, lens maker's formula, 1 by f is n of lens upon n of surrounding medium, which is air, minus 1 into 1 over r1 minus 1 over r2. So if I put it, it would be 1 upon 20. N of lens you know is 1.55, air is 1 minus 1 over r1. So if I take this as r1, so r1 as per our convention would be taken as plus r minus 1 over r2, and r2 means this one, and as per our convention it would be minus r because its center would be here, so the center of curvature's coordinate would be negative. So our sign convention makes r1 as plus r, r2 as minus r. Substitute it over here, it gives you 0.55, and you can write it as 2 upon r. So if we solve it, the value of the radius comes out as, it would be 20 into 1.1, which you can write it as 22 centimeters. So the radius of curvature would be 22 centimeters. So this is the way of solving this. In most of the books, or you can say the students preparing for competitive exams, they are directly told the formula that if you have a equiconvex lens, you can write f is equals to r upon 2 times n minus 1. So if I use that formula directly, it would be r is 2f into n minus 1, which again gives you the same result that I have written right now. That also gives 22 centimeter. But remember, in board exams it's more preferable to solve it in the way we first solved. For competitive you can remember this, but using this formula is more appropriate, because if the surrounding mediums is changed, then this formula direct one won't work. This works only when it is placed in air.